Hi all, welcome to my YouTube channel, Know About Embedded System. In this video, I'll show you how to read the pin status in 32-bit microcontroller. So how to read the status of port pins. If we have different port pins, how to read the status, whether the port pin is high or low. So how do you read that? That I'll show you with the programming exercise. So before proceeding to the video, please subscribe my channel. So now let us start the video, how to read the port pin status in 32-bit microcontroller. So as you know that guys already, I'm going to use LPC1768 microcontroller as a 32-bit microcontroller. How to read the port pin. In the previous video and in the previous programming exercise, we have already seen how to use the FIODIR, FIOSET and FIOClear. And even in the previous video, we have used FIOPIN, how to toggle the port pins without using set and clear. So in this video, that is nothing but how to read. So here you can see how to check the status of port pin. If you want to check the status of port pin, we have to use a register called as FIOPIN. FIOPIN stands for fast input output pin status information. Using this, we have to read the status. Now let us go back to the code and let us see how it looks like. I'll consider my previous program. This straightforward program here. Here I'll just write it, read the status of port pin. Read the status of P0.0. I want to read the status of port 0.0. You can take any port, but for me port 0 is comfortable. That's why I'm taking P0.0 here. So this is my program. So you can see here, this is my main program. So already the skeleton program is ready. Now what I'm doing here is, so one important configuration I'm doing here, line number 16. The line number 16, I'm doing configuration here. I'm making as an input port here. So P0.0 to 0.7, I'm making as an input port so that I can read the data from the ports. So this is the way to configure the input port. Then I'm going to use the register. I'm going to use the register here that is called as FIOPIN. FIOPIN. Okay, this is my register name. And first I will read 1-bit data. If you want to read 1-bit data, I need to create 1-bit mask here. So this statement, read 1-bit. I'm going to read our data from P0.0. Read 1-bit from P0. Okay, from P0.0. And so in order to read, I'm going to create 1-bit mask here that is called as 1-bit masking. So along with that, I need to perform AND operation with my 32-bit register FIOPIN like this. And then after doing this, and I will be using one variable here, integer read. So this is my variable, read 1-bit. I'll be assigning here. So that means what it is going to perform now. So this particular statement will read 1-bit of data. This is my 32-bit register. This is my 32-bit register, and this is my 1-bit mask. So both together, it is going to extract and it is going to store it in the variable called as read 1-bit. Okay. Now let us see whether will it work or not. Simple code. So save this code and run it. I will show you 4 use cases in this experiment, in this programming exercise: 1-bit, 2-bit, 4-bit, and 8-bit. I'll show you. Okay, so now let us go back to the debug window here. This is my port 0. You can see this is my port 0, and here this variable is there, that I need to add it here into the measurement variable as a measurement variable. Okay, so I have already read 1-bit here, and I will run here, and this is your port 0. You know that already. So this is my port 0, and currently I'm going to read only this bit because I have created only 1-bit mask. I'll be reading only 1-bit. What is the value of this? The value of this is now 1. So tick mark means 1. and untick is 0. In that way you can understand. Now what I will do, I will just execute the code here. Yeah, now you can see this read 1 bit is equal to 1, it is getting correct. I will just go on executing. It will be always 1 because the bit is 1. So now what I will do here, I'll just make it 0 this, and now I will execute. Now you can see, now read 1 bit is equal to 0, right? So now I'll make it 1 here, and again I will read, right? So this is how we're going to read 1 bit of data into the local variable. Okay, so this is how I'm going to read. So now this bit is 1, that's why here it is getting 1. And now what I'll do, I'll just make it 0 here. And now you can see the read 1 bit is equal to 0, right? So this is how we're going to read the port pin status. Okay, now what I'll do, I'll do the small modification in the code. I'll go for 2-bit now. For 2-bit, same procedure I need to do, but I need to create a 2-bit mask here. Okay, so now what I'll do, I'll do the same code, but I will rename the variable here. I'll take one more variable, read 2-bit, and FIOPIN will be same. Now I'll be going for 3 left shift of 0. Read 2 bits from port 0. That means port 0.0 and 0.1 it is going to read. I need to declare one more variable here. I'll just declare it integer. So now I have 2 variables here. Now let us compile. I hope you understood, right, what I did. So this is my 1-bit mask and this is my 2-bit mask, and this is a IO pin status. This will reflect status of port pin. Here I'm extracting 1 bit and here I'm extracting 2 bit. Now let us check in the debug window. Okay, so let us, now you can see this is my, now this time what I'll do, I'll add one more variable here. Okay, now let us go execution, step-by-step execution. Now you can see 1 bit is getting 1 and a 2 bit is getting 3 because it is reading now 2 bits. These 2 bits, your 3 bit is reading. So 2 bits currently 1, that is why the 2-bit mask or 2-bit variable is getting 1, 1. So now what I will do, I'll just make it the last bit 0. Now we will see what is the output. Now you can see, observe 2-bit mask, 2-bit read status. 2-bit read status is getting 2 because the first bit and second bit, first bit is 0 and second bit is 1. That is nothing but 2. Right? Now I'll take one more use case here. Let us check for this use case. Now this is 0, 1. My bit 2 should get 0, 1. Now you can see bit 2 is getting 0, 1. Similar to that, I'll go for last case 0, 0. Now you can see the bit 2 is getting 0, 0. So like this, we can read a different status from the port pins using bit masking. We have to use a bit masking and we have to perform AND operation with a 32-bit register. So try to understand what logic we have implemented here. So this part, what you are seeing, these two are bit masking. So this is a 1 bit and this is 2 bit and this is my 32-bit register. The FIOPIN, what you are seeing, this is my 32-bit register. So I'm just performing AND operation with a bit masking of 1 bit and 2 bit. So when you perform bitwise AND operation, wherever pins are set, those pins will be 1, and wherever the pins are set to low, those bits will be 0. So that is what you have seen in this experiment. All right. Now, so let us go back to the code, and this time I'll go for 4-bit masking, then I'll go for 6-bit masking. Now let us take the same code and do the small changes. I'll go for 4-bit coding, 4-bit masking, and then So for 4-bit masking, the F is a mask value, right? So this is my 4-bit masking. Comment says like this: read 4 bits from port 0.0. I'm going to read the 4-bit pin states. Okay, and then I need to declare this here as a global variable. We have to declare, or else it's not possible to get the variables in the software. So compile the code. So now let us go back to debug window here. So in the debug window, so currently I have three variables now. I have 1-bit variable, 2-bit and 4-bit. Now totally 3 variables are there. Let us check one by one what will happen. Now you can see the 1-bit is getting 1 because the first bit is 1. Now now you can see 2-bit is getting 3 because first and second bit is 1 1. Now you can see the 4th bit is getting F because 4 bits are 1 1 1 here. The 4 bits are 1 1 1 1. So because of this, the 4th bit 4-bit status is getting 1 1 1 is nothing but F. Okay, so now let us what I'll do is I'll just do small changes here, and for this we will check what will be the output. Okay, yeah, so bit 1 is getting 1 because bit 0 is getting 1, that's why. And the 2 in the 2-bit also it is getting 1, that's fine. Now I'll go for, now you can see. So try to understand here. So what is the value of this? 1001. 1001 is nothing but 9. That 9 is updating here, right? And one more case I'll take it. So this case I'll take. So now we will check what will be the output for 4-bit mask. Now you can see 4-bit mask is getting 7. So why it is getting 7? Because so now the first 3 bits are 1 1 and last bit is 0. Because of that it is getting 7. Right? So this is how we're going to extract, or this is how we're going to read the pin status from different registers and from the different port pins. Okay, so last use case I'll show you, and then we'll go to the next step. So last use case I'll take it 8. I'll go for 8-bit read. 8-bit read. Now I'm going for FF and I'll be reading 8. So final program, it looks like this. This is the last 8-bit port status read. Program is very simple. So this, you can see this is my main program. Yeah, I'm reading 1-bit data here by creating 1-bit mask and performing AND operation with FIOPIN. Then create 2-bit mask and operation with FIOPIN, create 4-bit mask and with FIOPIN, and finally create 8-bit mask and then perform bitwise AND operation with your FIOPIN status and read it in one of the variable, right? So just you copy that and declare it as a global variable. Now just save it and build it and rebuild it. So now let us check what will happen. So this is my port 0. I'll go one by one. So bit 1 is getting 1, bit 2 is getting 3. Now bit 4 is getting 4. Okay, I need to add bit 8 as well. So bit 8, let us check now. The bit 8 is getting FF. So why it is getting FF? Why it is getting FF? Because of this. I'm going to read 8 bits from the port 0.0 to 0.7. Because of this, it is getting FF. Correct, right? So now I'll go for one more use case. I'll just disable last 2 bits, and now let us check what is the output. Now you can see the data is reflecting as 3F. So why 3F? MS bit number 6 and bit number 7 are 00, nothing but 0303F it is, right? Like that. One more use case I'll take it for 8-bit mask or 8-bit, now you can see, for 8-bit reading. So in this case 3C it is getting. So 3C, why? Because here you can see it is getting data 0011 then 1100. So this is nothing but 3C, right? So this is how you're going to read a port pin status from your microcontroller ports by using two important logic. The first logic is bit masking. So we have to perform bit masking from which how many pins you have to use, from which position you have to read. So in this case, this is 1 bit, this is 2 bit, this is 4 bit, and this is 8 bit. So we are using 4 different use cases, and we're going to perform AND operation with status register, or you can say pin status register. Bitwise AND operation, and you can collect it in any one of the variable, and that variable you can display it. So I hope this video is clear to all. So with this, I'll just end my video. So please subscribe my channel and get notified, and click on bell icon to get a notification and to know more about embedded system. Thank you.